Hey there everyone, welcome back to Leetcoding. In this video we will be solving the second question of Leetcode weekly contest 220. Name of the problem is maximum erasure value. So this is the solution that I came up during the contest. The contest is still going on, and in case you have some better approach that currently I am not able to think of, please comment on below. Now let's read the problem statement and start solving the problem. You are given an array of positive integers nums and you want to erase a subarray containing unique elements. The score you get by erasing the subarray is equal to sum of its element. Return the maximum score you can get by erasing exactly one subarray. An array B is called a subarray of A if it forms a contiguous subsequence of A, that we already know. So basically in this case what we can do is we can erase the element 2, 4, 5 and 6 because this is a subarray and it contains only unique elements. So the summation is 17 and this is the optimal answer. Next, in this we can either erase 5 to 1, that is this subarray, or we can erase 1 to 5, that is this subarray. And if we try to go beyond this, like if we extend this to the right, then we will not have unique elements because 2 is appearing twice. Similarly, if we try to expand this to the left, the same will happen here as well. So the maximum summation that we can get in a subarray which have only unique element is this much, 8, 1, 2 and 5. Alright, now let us see how we can solve this problem. Let us go to the whiteboard for that. So let me quickly pick up the example. It is 4, 2, 4, 5, 6. 4, 2, 4, 5 and 6. So these are the elements. Now what we can do is we can start reversing from the beginning. We can start reversing from here. Then we know that this is only unique element as there is no 4 behind this. Then we can come to this element and we will see that this is also unique because there is no occurrence of 2 behind this. So we can include this as well in the answer. Now our answer is 6, 2 plus 4. Now as soon as we come to this 4, we know that there is already 1 4 behind this. How we can know this? For that we can use a map or we can use a vector as well to store the elements and their indices corresponding to the elements, the way we do in maps. So here the constants are given as 10 raised to the power 4. We can either use a map or we can use a vector to store the elements and then their indices corresponding to the element. Here we know that 4 occurred at the index 0, 2 occurred at the index 1. Again when we are at the index 2, 4 is occurring, and we will know from our lookup table or from our map that 4 has already occurred and it occurred at the index 0. So what we can do is we can try finding the summation from the index 1 till the index 2 because 4 already occurred at the index 0. So now we will have to find the summation from the index 1 till the index 2. Next we go to 5 and we know that there is no occurrence of 5 when we look into our lookup table or our map, and that is why now we will have to find the summation from the index 1 till the index 3, as we have already shifted our starting point to the index 1 just because of this 4. Next we come to 6. Again we will have to find the summation from the index 1 till the index 4. Let us see the other example. I think that will make things more clear. So this is the next example. Let me first index them. Alright, so now our lookup table is empty. There is no element. And our starting index from where we have to find the summation is also 0. So this is our starting index and it is 0. So from here we have to find the summation. When we come to 5, we will have to find the summation from 0 till 0 and the summation will be 5. So this will be our answer. Next, when we go to 2, also we will have to store the index 0 corresponding to index 5. Next, when we come to index 2, we will see into our lookup table there is no occurrence of 2. So That is why our starting point will remain 0. So as there is no occurrence of 2, we will have to find the summation from 0 till the index 1, because the starting point is still 0. So the summation will be 7 and the answer will be 7, as it is the maximum. And corresponding to 2, now I will store 1 because 2 is occurring at the index 1. Next we are going to 1 and there's no occurrence of 1 behind this. So again the starting point will remain same, and we will have to find the summation from 0 till the index 2, and the summation will be 8. Now corresponding to 1, I will add the index 2. This is our lookup table actually. This is our lookup table. And this is our starting point. Now when we go to 2, we will find in our lookup table that 2 already occurred at the index 1. So now our starting index will become just after 1, that is 2, because we will have to ignore all the elements till 1. So we will have to ignore all the elements from the starting of the array till 1. So now our starting point will become 2, that is the index at which 2 occurred plus 1. So our starting point will now become 2, and the summation we will have to find from the index 2 till the index 3, and that is equal to 3. So 3, and it will not change the global answer because 8 is still the maximum. Next, when we go to 5, also we will have to update the position of 2 now. The position of 2 in our lookup table will now become 3. We have to update the recent position, the most recent position. Next is 5. In the lookup table we will see that 5 is occurring at the index 0, but our starting point is already 2, so we won't change the starting point because we cannot go behind actually. So our starting point is not going to change, but corresponding to 5 we will be inserting the index 4 in our lookup table. Also we can find the summation from the index 2 till the index 4. The summation will be 8. The global answer will still remain 8. Then we come to 2. So for 2, if we look into the lookup table, the index is 3. So 2 is occurring at 3 and our starting point was 2. So now our starting point will change. Now it will become 4. 3 plus 1, 4. This will be our latest starting point, and we will have to find the summation from the index 4 till the index 5. The summation will be 7. Corresponding to 2, we will update 5, and we will carry on this process till the end. So I hope you got this. Another thing is, each time when we are computing the summation from a certain index starting point till the current index, then it is going to take big O of n, and the entire process is again going to take big O of n. So the overall complexity will become big O of n square. But as the constraints are high, the constraints are given as 10 raised to the power 5, we won't be able to solve this in 1 second. So for that, what we will have to do is we can maintain a prefix sum array. In order to find the summation from a certain starting point till the current index, we can maintain a prefix sum array, and using the prefix sum array, finding the summation from given L to R would be computed in big O of 1, that is in constant time. So for those who don't know what prefix sum, it is simply the summation from the index 0 till the current index. So if I draw the prefix sum for this array, it will become 5. Then the next index will be 5 plus 2, 7. Then next will be 5 plus 2 plus 1, 8. Then 5 plus 2 plus 1 plus 2, 10. Then plus 5, that is 15. Then 17, and so on. And if I want to find the summation from the index, let us say 1 till 3, so from here till here, what I will have to do is I will have to look at the element present at the index 3 and subtract the element which is present at the index 1, that is 2 minus 1, so just behind this, and that will be equal to 5. 10 minus 5, 5, and we can see the summation is 5 from the index 1 till the index 3. Alright, now let us go on and try to implement this. So let us first create the prefix sum array. N is the size of the array nums. The prefix sum array which I am creating will be 1 based indexing. So at the index 0 I will place 0, and it will help me in the further implementation, basically writing less lines of code. So p of I plus 1 will be equal to p of I. This is just 1 base indexing. You can pause and just think about it once. Now we are done with the prefix sum array, and we are keeping s is equal to 0. This is our starting point. Now we will run a loop from int I is equal to 0, I is smaller than n, I plus plus. We are going to each of the element in the nums, and also we will have to keep a map that I was talking about. Instead of map, I am keeping a vector. I think this is the range for the elements, so I think this will be enough. Now in this m, I am going to keep the index corresponding to each of the element, but as of now there is no element that I have seen, so I am keeping -1. Alright, now first of all, s will be equal to maximum of s comma m of nums of I plus 1. Now we will have to find the summation starting from s till the current index I, and that will be answer. So answer will be equal to maximum of answer comma p of I plus 1, because it is 1 based indexing, minus p of s, and then I will have to update our lookup table. Nums of I is equal to I, and finally I can return the answer. Let me create the answer as well. Let us run this code. 17 and 8, 17 and 8, and it got accepted. So talking about the space complexity, we are using a prefix sum array, and that is big O of n. Again, this lookup table is big O of n, where n is actually the range of the numbers. So it is big O of n in terms of space. In terms of time, it is going to be big O of n as well, because here the loop is big O of n to compute the prefix sum, and here also the loop is big O of n. Now let us move on to the next question, and if you like the video, please subscribe to the channel and press the bell icon so that you can get notifications to our videos. Thank you.